Hello, my name is Ken Owens, and I'm a technical support analyst with the Identity Management team focusing primarily with the Oracle Access Manager product. I would like to welcome you to the Oracle Identity and Access Management Insight session titled Introduction to Logging, Tracing, and Diagnostics for the Oracle Access Manager 11G and 12C versions. This technical audience, who are charged with resolving Oracle Access Manager loss of functionality issues either on their own or via an Oracle support service request. Today's agenda will cover an overview to define the scope of this presentation, then proceed going over topics like general information, methods for enabling logging and tracing, potential pitfalls, and a comparison of the diagnostic log with or without trace, and wrapping it all up with a quick summary. My thought for this presentation was to pass on from my experience with the OAM product a direct, simple approach to logging and tracing that can assist in resolving technical issues. For more detailed information on this topic, I will refer you to the Oracle product-specific documentation. For a quick start reference on this topic, I'll refer you to a KM note, which will be listed later at the end of this presentation. In regards to logging and tracing, we will discuss a little about the WebLogic admin server, which runs the OAM console, and a little about the OAM WebGate. But the main focus will be with the WebLogic managed server that runs the OAM server. After this presentation, you will be able to see the difference between the diagnostic information returned in the component-appropriate log file, non-trace versus trace, be aware of the different methods for enabling diagnostic trace, have a better understanding of the basics required for logging and tracing and diagnostics and why it is needed, and potentially resolve the loss of functionality issues on your own or have the needed data to provide at the creation of your Oracle service request. The OAM diagnostic log entries can be key to finding the cause of a problem with an OAM implementation. By default, the OAM server is configured to log at a notification level, which provides some useful processing information. However, there will be occasions when a higher logging level is required in order to obtain more information about a technical issue. When should we turn tracing on? It all just depends about one's troubleshooting process. For me, I first like to understand what the end user sees, understand what is the loss of functionality and the steps followed to get there. Then I like to simplify the environment as much as possible to a point of where the issue still reproduces. This makes logging and tracing a bit easier in regards to what is turned on and what log files are collected. Once I have come to a point where I've utilized all the resources and techniques to try and resolve a technical issue, but with no success, I then move to tracing. Logging is the mechanism by which components and services write messages to a log file in order to capture critical component events, processes, and state information. Administrators can configure logging to provide information at various levels of granularity using the same logging infrastructure and guidelines as any other component in the Oracle Fusion middleware product stack. Log levels. Support will typically ask for the log level of 16 or 32. For more detailed information on the available trace levels, refer to the product-specific documentation. Component loggers. Support typically turns on all OAM loggers. For more detailed information, please refer to the product specifics. We'll actually show you the two that are the most common used later on in the demonstration. And then we use the execution context ID, which we refer to as ECID. And this value allows us to track subsequent messages that refer to the same transaction through the log file and to the other component log files that are related to it. The WebLogic admin server's logging file is called logging.xml and is represented in green. The logging file location format is represented in red, and the logging file location example is represented in blue. The same information for the WebLogic admin server also applies to the WebLogic managed server. The OHS 10G, 11G, and 12C WebGates, the logging file is called oblog_config_wg.xml and is represented in green. The logging file location format is represented in red, and the logging file location example is represented in blue. What you see now on the screen is for the 10G WebGate. And this is for the 11G WebGate. And this is for the 12C WebGate. The WebLogic admin server's log file is called admin_server-diagnostics and then a number value .log and is represented in green. The log file location format is represented in red, and the log file location example is represented in blue. The same information for the WebLogic admin server also applies to the WebLogic managed server, except as you can see in green, the name of the diagnostic file will be the name of the OAM server -diagnostics and then a numerical value .log. The OHS 10G and 11G WebGate log file is called oblog.log. The OHS 12C WebGate log file is called webgate.log and is represented in green. The log file location format is represented in red, and the log file location example is represented in blue. What you see on the screen now is for the 10G WebGate. And this is for the 11G WebGate. And this is for the 12C WebGate. There are three methods for enabling trace for the OAM server. There is the GUI interface used for the EM console, the command line tool that uses the WLST commands, and manual edits to the logging.xml file. The 12C EM console has more than one way to navigate to turn on logging and tracing. What will be shown is just one of them. The slides that will be shown are from a 12C environment, but look pretty much the same as an 11G environment. Step 1, access the EM console. This will bring up the login screen. Step 2, log into the EM console as an admin user like WebLogic. Step 3, from the WebLogic domain home, select the server name OAM_server1. This will bring up the OAM server 1 screen. Step 4, select the WebLogic server dropdown and navigate to Logs and then to Log Configuration. Step 5, in the Log Levels tab, enter oracle.oam in the search text box, then select the click on the search button. Step 6, from the search results, choose the ODL level as trace32 for the logger name oracle.oam, then click the Apply button. Step 7, this brings up the confirmation page. Select Close. Step 8, follow the above steps 5 and 6 to enable log for logger name oracle.security. This completes the steps for using the EM console to enable logging for the WebLogic servers. In this specific case, it was the managed server that runs the OAM for trace32, for the OAM loggers oracle.oam and oracle.security. When finished collecting the trace logs, just do the reverse to undo the changes. We will now go over the steps using the Oracle WebLogic scripting tool. Step 1. Set the OAM environment variable by opening a command prompt, then changing to the directory as shown on the slide, and then executing the set domain env script. Step 2. change to the directory shown on the screen, then execute the WLST script. You will see a message like what is shown on this slide. Initializing WebLogic scripting tool, welcome to the WebLogic server administration and shell script, type help for an available command, and then it brings you to the WLS offline prompt. Step 3, enter the connect information as shown on this screen. So basically, to get started with that, you would just go ahead and use the function connect. And when you start that function, it will prompt you to add a username, to put your password, and then to enter the connect information to the WebLogic server that you'll be communicating with. Step 4, at a prompt, type the function domain runtime as shown on this page. From the prompt, we will now see WLS:/base_domain/domain runtime/greater. We want to enter the function as seen on the screen to get the logger of oracle.oam and the trace level of 32. Then we want to enter the function as shown on the screen to set the logger for oracle.security and the trace level 32. Note that when the persist is set to the value of 0, the log level will revert back to the previous state after the OAM server is restarted. If it is set to 1, then the log level will persist even after the OAM server is restarted. Step 5, verify the log level has been changed for the logger oracle.oam by executing the function as shown on the screen. Then do the same for the oracle.security by executing the function as shown on the screen. Step 6, to exit the WLST tool, enter the exit function as shown on the screen. Let's do a quick recap. Note that when the persistence is set to 0, the log level will revert back to the previous state after the server is restarted, whether it's the admin server or the managed server, either one. And if it is set to 1, then the log level will persist even after the OAM server is restarted. After the issue is reproduced, revert the OAM server log level to the notification by using the functions as shown on this screen. This completes the steps for using the WLST tool for enable logging WLS servers for the admin and managed server at trace32 for the OAM logger, oracle.oam, and oracle.security. When finished collecting the trace logs, just do the reverse to undo the changes. Now we're going to go over how to manually edit the logging.xml file to turn off tracing. Step 1, change to the directory as shown on the screen. Take a backup of the logging.xml file before making any changes. Step 3, add the entry before the logger section in the file as shown on the screen. Step 4, no restart is needed for logging change to take effect. When finished, save the current logging.xml file to a meaningful file name so you could use it later on when you want to set trace again. Then copy the original logging.xml file that we backed up back to logging.xml, and this will revert us back to our changes prior to making any changes. That's all there is to it. Next, we're going to talk about the OAM WebGate. There's only one method to enable trace and logging for the OAM WebGate, and that is by manually editing the oblog_config_webgate.xml file. Step 1, make a copy of the oblog config wg.xml file. Step 2, edit the oblog config webgate.xml file, and in there you want to navigate to find the parameter log threshold _level, and we want to change it to log level _trace which in the screen you'll see that's in green. And then we want to also find the section in there that the parameter name is buffer size, and we want to change that value to 0. By changing this value to 0, it ensures that the trace information is not buffered and is flushed instantly. Step 3. Once the issue is reproduced and the data is captured, revert the changes to the OAM config_webgate.xml file using whatever method you want. Now we'll go over some potential pitfalls that you can run to when turning on logging and tracing. Performance. When the log level is set to trace 16 or higher, there's a potential for performance issues. In a production environment, this log level is used in a predetermined maintenance window. It is a best practice when possible to reproduce the issue in a lower environment and use the higher log levels there. Disk space. When using higher log levels and multiple component loggers, there's a potential to generate a lot of log files. It is best practice that when doing so to keep an eye on the free disk space. Log file rotation. The OAM server, in some cases, the amount of trace collected may be overwritten and would no longer reflect the actual issue time frame. This would require that the size of the log file need to be increased. Refer to Chapter 7 of Managing Log Files for more information on how to avoid this. The OAM WebGate. By default, there is no size limit to the generation of the log files, nor there are any log file rotations. When you have your log files, you want to make sure that it's from the same date and time and from the frame of where you see the issue. So when you go to upload the files to the service request if needed, the right information will be there and they'll be able to move forward with it. Now we're going to move on to where we compare the OAM server diagnostic log with trace set and without trace set. The intent here is to show the information provided in the OAM server diagnostic log differs from the default outbox setting of trace level. To demonstrate the difference, we will use a very simplistic scenario where the authentication fails. We will not be going over on how to analyze the resulting log file, nor will the issue be resolved via the data found in the corresponding log file, but it will demonstrate how tracing increases the information to the log and can provide some insight to the issue. Step 1, just open up a brand new browser session. Step 2, call a protected resource and the OAM login page will be displayed. Step 3, enter your username and password. And then step 4 is where we see authentication failed error returned. Typically, for an issue of this kind, the first step to resolve would not be to turn on tracing. First, we would try to clarify the issue by asking some basic questions. Has this ever worked? Are other users having the same issue? Are we sure the correct username and password was entered? Do we see the same symptoms if we tried it in another browser? Do we see the issue or symptoms if we tried different protected resource? Next, we would try to reproduce the issue with the least number of components running. This makes tracing easier to run and collect. 2 good notes to help with troubleshooting are shown on the screen. The Oracle Access Manager 11G Troubleshooting Master Quick Start Guide and the Oracle Access Manager OAM 11G WebGate Troubleshooting Quick Start Guide. Basically, if we just leave it with the out-of-box notification turned on, which we'll see, so this would be no trace, we just see the initialization of the LDAP connections. There are some references to host names and ports that may be useful. So if you look on this output here, we actually see the host name and port of where the request is coming from. We do see that the libovd piece is making the communication to do it, and we see the host name and port that it's trying to communicate to the libovd. As stated earlier, there are three methods in which we can turn on trace for OAM server. They are with the GUI tool for EM console, or with the command line tool, WebLogic scripting tool, or by manually updating the logging configuration file. We use the OAM server only Oracle.OAM logger and trace32 level. No matter which method is used to turn on logging and tracing, it adds the following to the logging.xml. And that's what we see in red. That's the little piece that if you were to make a backup copy of the logging.xml file and look at it, and then go ahead and turn on tracing for the Oracle.OAM and trace32, you would navigate down and you would see this entry in there. All right, so we went ahead and we turned on tracing, and in the resulting OAM Server 1 Diagnostic 1 log, we searched for the user who submitted it, what was called user.fail. And we see that that's represented in blue. Also note that in green is the ISID number for this transaction, and in yellow is, we see that it is showing a trace level of 16. Now here, this next section of the log, we would go ahead and we would search for the authentication module name, and that's represented in the blue section. And we can see what that information is. It's called the LDAP plugin. And you can see that the ISID number is the same as the ISID number in the previous snippet of log that we looked at, so we know it's the same transaction. In this last little snippet that we show, we want to go ahead and search on the failure. So we search for the word failed. We find it, and it's represented in blue. And we see the OAM error code, which is represented in red. So you can see with the trace turned on, we do get some more detailed information that could possibly help us resolve the issue. Today we have covered general info and regarding to the terminology, logging configuration file name and location, and the resulting log file name and location. Methods for enable logging and tracing using the EM console, WLST commands, or manually editing the logging.xml file. We identified some potential pitfalls like performance, disk space, log file size, and the importance of collecting the correct data. And most importantly, I hope you now can see with trace turned on, we're able to get more detailed information that can help resolve a technical issue. As a reminder, the information presented in this presentation is also in a CAM note called Quick Start Guide to Enabling Enhanced Logging for Oracle Access Manager OAM 11G and 12C Components, Doc ID 2463852.1. This is a living document and will change and grow as new information becomes available. Thank you again for tuning in to today's Oracle Identity and Access Management Insight session titled Introduction to Logging, Tracing, and Diagnostics for Oracle Access Manager 11G and 12C versions. We look forward to seeing you at the next one. Have a nice day. Goodbye.